Ladies and gentlemen, let's get to it. So here's what we're doing today. We have a quiz at the end of the day, and the stuff on the quiz is actually having to do with the stuff you're about to take notes about, notes on, excuse me. And then we're going to back that up by looking at the consolidation activity on 5.3. So please take notes. So here's how we're going to do this. The first thing we're going to do is I'm going to go through these notes, and the reason I'm doing it by video is simple. This way, if you need to hear something again, you're not. I'm going. You need to see me write something twice. You can always rewind the video, where you can't necessarily make me rewind in real life. So I want you to go through this at your own pace. If you need to rewind, you need to see something twice, go ahead and do so. But for everyone, as soon as you're done, you're going to go to page 190. Whoa, go back. You're going to go to page, come on, give me that pen. Page 190, and you're going to do the 5.3 consolidation. Okay, that's going to be kind of the proof in the pudding that these notes were effective for you, okay? So let's talk about scaling graphs from tables and equations. Now, don't get freaked out by this term scaling. Now, all that really means, and I want you to please write this down with me, scaling means picking and labeling numbers for the axes, okay? The axes of the graph. So in other words, what are you going to count by x? What are you going to count by y? Like when you put it on the graph, like how do you choose those numbers, okay? And we did have some problem with that on the last test, so this is going to be very appropriate for us. So here's how we're going to start this. So we have this table data that we graphed, and two students graphed them, and they're both graphs are actually correct, kind of, but one graph is clearly better than the other. Like this guy over here is clearly the superior graph. So it behooves us to take a second and kind of vet out why this graph is so superior. So like if this is like you, and you're asking a good question like, what makes a graph a good graph? Now you don't have to write this part, obviously, but I do want you to take these notes. So what makes a graph a good graph? Well, we can do that by talking about why this guy on the left is so bad. Well, one thing I can definitely think that makes a graph a good graph, why the graph on the left is so bad, is look at this. Look how hard it is to read. Like if you're looking at these blue points on the left and the blue points on the right, and again, they came from the same table, you get the impression that the blue points on the left are kind of just a straight line. Whereas on the right, the one I have highlighted in purple, it's really clear to see it's increasing. Now, if you look at the table, the numbers are clearly increasing. Okay? So that's something to consider. Like if the numbers are clearly increasing, but your graph doesn't make it appear so, that's probably a bad graph, which means a good graph should be really easy to read. Okay? In other words, spread out. Like it should be spread out. Or not smushed if you want to put it in the negative sense. Okay, so the other part is that it should be really easy for the user to make. Okay, or to label. If you look at this graph, man, look at all those individual tick marks. Look at all those tick marks. Like that's me having to label all these numbers on every single tick mark. No thank you. There's no way I'm doing that. Like you ready? How would you guys say it? You're doing too much? That's doing too much. Now over here, if you look, there's only one. Ooh, come back there, highlight. There's only 1, 2, 3, 4 things I'm actually going to label on my y-axis. There's only 1, 2, 3, 4, 5, 6 things I'm going to label on my x-axis. That makes it easy to label. Now another thing that every good graph should also have is that it should always show the axes. Okay? We should never be devoid of actually locating these axes. So when we pick a scale what we're going to count by, we should always make sure we see those. And the last thing is definitely should show all the data. Okay? So in other words, we shouldn't leave a point out. Now, if that's our mentality, it should be pretty easy to pick out what we need to do to make a good graph. So let's get to it. If we know we have to make graphs easy to read, spread out, easy to label for us, show the x and y axis so you know where in the world the graph even is, and it has to show all the data so we're not leaving any points out. That should have some pretty easy rules for us. Okay, so how does that play out? Well, let's talk about the essential question. Here's the question you should be able to answer by the end of these notes. That question is, how do I pick numbers? Pick numbers to scale the graph of a table or equation. Okay, which is a kind of a different beast, but you'll see it's kind of the same thing. So that's our essential question. That's where we're starting. How in the world do I pick the numbers to scale the graph of a table or an equation? Well, we can do that again by simply examining this table. We can come up with a set of rules. I think what we really need is a set of steps or a set of rules in which we will be guiding, or which will guide our kind of behavior and our decisions. So here's what I have. If I'm looking at this table, I'm looking at this graph, which was really well done. The first thing I think I need to realize is that I need to find the highest and lowest numbers. So I have the 10 and I have the 12. Now they're not always going to be the two ends, and you should probably take note of that, because you have to be really kind of sharp to make sure that you're just not picking the first and last number. We have to make sure we're picking the highest and lowest number. And we also do it for the y-axis as well. So we have 0 scanning across 1.5. Now in this example, they were the first and last number, but caution, they won't always be. So make sure you know that. But I think that's the first step in doing this well, is we have to find out what our limits are. So we need to find highest, lowest numbers for x and y. Okay, so that tells us kind of our limitations. Now, in this particular case, 0 and 0 being what they are will help us actually see the axes, but that's not always the case. So there is a step 2 here, and step 2 is picking min and max so they show axes, always show the axes, but cover all needed values. Okay, now it'll make sense in a moment, I guarantee. If that doesn't make sense right now, that will. Have a little faith, okay? So then the last step, I think, is kind of related to step 2, is we have to figure out the increment, so we aren't doing too much, but also hit the min and the max. Okay, so here's kind of how that plays out. So I'm going to take you through all the steps here. So we already found the highest and lowest numbers. So now we're on step 2. We have to pick a min and a max so they show the axes but cover all the needed values. So the min is 0, the max is 12 on x. And if you can look, that's probably 0 right here. And then this is actually probably 12 at the very edge of the graph. Now that covers all the values. Now on the side, we have 0 to 1.5. That's probably 0. And if you look at this one, that's actually above 1.5. My guess is that's 2. So here's what I was talking about when I say you have to cover all the values and see the axis. Even though 2 is not the biggest number in the table, it still is above the biggest number, so it covers it. So 1.5 will still be shown even if it's not all the way to 2. All right, so now the last step is we have to figure out an increment so that we aren't labeling too much, but also hit the min and the max. So if I went from 0 to 12 and just counted by 1s, that actually wouldn't be too terrible, but I'm going to count every single number. So my thought process on this is to do a couple things. I'm going to ask myself, well, what in the world is a table counting by? Is it counting by a consistent thing? And it turns out it is. It's counting by +2. So that's going to help my thinking process. And also, labeling 12 things counting by 1 versus labeling every other thing counting by 2 gives me an advantage. So that's going to be a 2, 4, 6, 8, 10. Yeah, so counting by 2s definitely gives me an advantage here because I don't have to graph too much. I have to count by the same number each time, mind you, so I can't go like, 1, 2, 3, 7, 12, 15. But I'm going to count and spread that out a little bit, and my thought process up here is at least using the numbers that the table's counting by. Now on the bottom, I have to go from 0 to 2 because I chose that as my max. So I want to make sure I'm choosing numbers that get me to 2, but again, I'm not going to be doing too much. I'm not going to count by like 0.01s. That's way too many. But what I can do is make sure I'm going to 2 evenly. Now here's an exercise and kind of what we talked about in the opener. You can't use just the numbers in the table. You have to use the same number every time. So this one's actually counting by 0.5s. Okay, and counting by messed that up. Sorry about that. That's what happens when I try to talk and do something at the same time. Okay, so count by 0.5 get me to 2. It's very spread out. It's very easy to read. I'm not doing too much. And I'm also making sure I'm following that rule. I'm using the same number every single time, okay? So let's go on to the next one. Let's see a quick example. Well, let's decide on the scale of the graph by looking at the given table. Let's go through our steps. So step 1 absolutely is going to be to find our minimum and maximum values. So again, I'm going to read the whole table to make sure I'm doing it well. For my x, I have 3 and 1. That turns out to be the beginning and end. Now in this one, oh, it's not at all. -3 is my smallest value. 23 is my big value. So again, we have to be careful not just to choose the beginning and the end. Those are the numbers that have to be on our graph. Now let's take us through the logic. We've chosen the highest and lowest values for x and y. Now we have to pick a minimum max so they show the axes, but they cover all the needed values. Now the axes are at 0. So we're definitely going to be taking care of that because we got to go negative to positive. But now we have to make sure we're choosing numbers that cover everything. So -3 to 1, like those actually might be pretty okay choices. And that's because from -3 to 1, there's not much there. And I can count by numbers that are reasonable. Like I can count by a 0.5 or I can count by a 1. So I think I might just go ahead and choose -3 and 1 as my limitations. Now, what am I going to count by? Well, that's why I have to make a decision. So the first thing I'm going to do is come back to my table and decide, well, what was my table counting by? Is that counting by something consistent? If my table's counting x's by something, maybe I should too. And it turns out it is counting by 0.5 each time. Okay, now 0.5 isn't too bad going from -3 to 1. I'll just have to put like 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll have to do like 9 marks, but 9 marks isn't too many, so I'm going to count by 0.5s. Let's do a similar analysis on the y. So we have to go from 3 to 23. Now if I just choose -3 and 23, what am I going to count by that hits all those numbers? I don't think I'm going to get anything. I don't want to count by 1s because like that's going to be like 26 numbers. So if you imagine what that looks like that's me on the graph having to write out 26 numbers to go from -3 all wherever it ends up to 23. I don't want to do that. That's just bananas crazy. I don't want to do that. So I need to kind of maybe expand this a little bit. Like these numbers weren't actually very good choices. So what I kind of want to think about is what do I want to count by? Like that's my next thought process. What do I want to count by? Okay. And the reason I asked myself that question is because I know I have to get to -3 and 23, but it doesn't mean I can't go a little bit beyond it. So here's what I'm going to do. Let's see if you can follow the logic. I'm actually going to go to -5, which is below -3, so I'll still cover it, and I'm going to go up to 25. So I'm going to, if you kind of think again about the picture of the graph, I'm going to go down to -5 and then all the way up here to 25. And that's going to be okay because 23 is below it and will be covered, and -3 is above -5 and that'll be covered too. The reason I chose 5 and 25 is because if I do choose that, I'll be able to count by 5s, because counting by 5s, I can hit both those numbers really, really well. That's not the only choice. I'm going to give you an alternative, okay? A reasonable alternative would be, so I'm going to draw a line because this is the alternate. I could go from -3 and then go up to, say, 24. And then if I'm going to do that, I might count by 8s. Okay? That's a weird one to do, but you certainly can. That's an equally viable alternative. Another one might be, say, go down to -4 and then go up to 24 and then count by 2s. Because again, they're both even numbers and 2 will cover them both. They're all pretty good ones, but again, it's following our process. And the last one is make sure you're incrementing, so you're labeling everything, you're not doing too much, and also you're hitting both the min and the max numbers. And since I have to get to 23, either 25 or 24's choices would be okay. Right? Let's look at this last one together. So I have to do the same thing, but I have to use this rule. Now, we did all this work on a table, but now I'm giving you a rule. So of course you're stuck, right? No, you're not stuck. What that means is you got to make your own table. So we're not giving you any additional instructions on like what you actually have to use for your table. So you can pretty much use whatever you like. So there's 2 standards I'm going to introduce you to. If you're not given anything, you probably want to use about 10 numbers. So sometimes the standard becomes going from -5 to 5. What I mean is going from -5 on the x. I'll have to split my table into 2 parts. I'm sorry for that. Going to -5 to 5 and letting that kind of dictate your y. So what this actually tells us is our min and our max, because we have to choose it, is going to be -5 to 5, and we'll count by 1. So the other standard you might want to think of is negative 10 to 10, which will become more of a standard when you get a graphing calculator going with this, okay? So now to figure out the y min, I have to fill in the table, I think, at least for now, hint, hint. But I'm going to do that really intelligently. So I know this plus 1 transports itself to be across from 0, so I know that's going to be a 1. And then I also know that this 2 dictates how much I'm going up or down in my table. So in other words, if I go down another value, that's another plus 2, which that means this is going to be 3 over here because, again, I'm continuing my table. And that's going to be 5, 7, 9, and that's down to 11. And it also means if I reverse myself, I'm going back 2. So that's going to be like negative 1, negative 3, negative 5, negative 7, negative 9. Okay. Now from here, for my table, it's going to be used as normal. So now I'm going to pick the min and max. So we have this negative 9, we have this 11. So I'm now deciding what I'm going to count by. Again, 9 and 11 kind of seem weird. I guess I could use them and count by 1s. But again, I'm going to use my good rules. I'm going to drop just below negative 9, go to 10. And then I'm going to go just above 11, go to 12. And then I'm going to count by 2s. Okay. And the logic behind that is so I'm skipping every other number. I'm not doing too much, but I'm still covering the beginning and ending numbers. Okay, so if I want to bring this to a conclusion, it seems to me we decided some really good things. So 1, what a good graph should look like. 2, it seems like we can answer our essential question: how do I pick numbers to scale the graph? And we're going to do that by looking at the highest and lowest numbers for x or y in a table, even if I have to make that table myself. Pick the min and max numbers so that it shows the axes, the x and y, and they cover all the needed values. And then figure out what increment we aren't doing too much, and so we hit the min and max. So like in other words, we're not negative 3 to 23 counting by 1s is way too much, but I could do negative 5 to 25 counting by 5s. That's only going to be like 6 things. And then negative 24 to 24 counting by 2, which that's going to be 14, which is quite a bit, but at least it's more than what it would be counting by 1s, okay? If you give it an equation, that's okay. You just make a table for it. Sometimes they tell you the value, sometimes they don't. But you can make a table for that. What you're looking for still, though, is your smallest and biggest number, and there might be a clever way around that, making a whole table. And it has to do with the min and max, but you can make a table and then you can go from there. The last note I'm going to give you is if you think about this equation, okay, and you think that I have this negative 5 and 5 as my min and max, you might be able to use that information to actually produce the numbers you need. Let me tell you what I mean. So if I want like the min value, well, I know the min value is a negative 5. It says so right here for x. I can just run that in my equation. Check this out. Y equals 2 times 5 plus 1 means that's going to be 11. Hey, look at that. 11 was my max value, or one of my values, I should say. And then, oh, I'm sorry, that should be negative 5, shouldn't it? That should be, I apologize for that, guys. I wasn't being careful. So that'd be, negative 9, excuse me. And look, my min value is negative 9. Then if I want my max, I have y equals 2 times 5 plus 1, and that equals 11. But look at that, 11 is right there. And those were the actual numbers you were kind of caring about. So you could make your whole table. I'm kind of suggesting you make a shortcut. All right, so guys, review your notes, and then go ahead and start page 190, consolidation. Okay. I'll give you guys a few minutes to actually do that. Then I'm going to ask for some volunteers to present the work, and then you guys can be off on your quiz. So I hope this helped. Thank you guys for taking these notes. You can use these notes in the quiz, by the way. Hint, hint, nudge, nudge. So I'm happy that you guys took them. All right, you guys get to work. Thank you.